This is the solution to number 8 on the AP current electricity problem set. Let's once again start by reading the question. A 4 ohm resistor, so we would call that R1, an 8 ohm resistor, R2, and a 12 ohm resistor, R3, are connected in series. Really important piece of information there, with a 24 volt battery. Of course, that's our voltage. What are the equivalent resistance? Okay, so that's our total resistance, also called equivalent or effective resistance, and the current in each resistor. Okay, so they're looking for I there. And then in C, they want us to repeat this problem by connecting them in parallel. Okay, so we'll come back to that when appropriate. All right, so we're going to start this problem by drawing the circuit. I would greatly encourage you to do that every single time. And so we're going to start by taking a battery. There's our 24 volt battery. And then we need our 3 resistors in series. So we'll take 1, 2, 3. We'll turn this one sideways. Connect them with appropriate wires. Label them R1, R2, R3, and R1 was 4 ohms. R2 is 8 ohms. And R3 was 12 ohms. That's everything we're given in the problem. We're now expected to A, calculate the equivalent resistance. Alrighty. Alright, so in series, how do we calculate equivalent resistance? We go to the reference table and we see that the resistance in series is simply the sum of the individual resistances. And that's pretty easy. We'll even write our information down here. 4 plus 8 is 12, plus 12 is 24 ohms. All right. B wants to know the current in each resistor. Well, the current in each resistor is the same as the total current because in series, current remains constant. So what they're really asking us for in B is the total current in the circuit. In order to calculate the total current or any total electrical quantity, you always have to use other total electrical quantities. Well, what do we know? The formula for current would be V over R, and we know the total voltage is 24 volts. And we know the total resistance is 24 ohms. And so we know 24 divided by 24, our total current is 1 amp. Pretty simple introductory problem there for a series circuit. They now want us to change this and make a parallel circuit and answer the same questions. So we're going to start off once again by drawing that. And we're going to need another battery. We're going to need our 3 resistors. We'll drag them down here and we'll readjust. To draw them in parallel means they each are on their own separate branch. Okay, and then we're going to go ahead and connect them with appropriate connecting wires. We'll label everything in our diagram. Still 24 volt battery. 4 ohms, 8 ohms, and 12 ohms. R1, 2, oops. Erase that. R2 and R3. Okay. So again, they want the equivalent resistance. We go to our reference table. How do you calculate equivalent resistance in parallel? The total, the reciprocal of the total is equal to the sum of the reciprocals of the individual resistors. Remember our rule of thumb that we mentioned earlier in our notes is that we already know before doing this problem that our total resistance has to be less than the smallest resistor in our circuit. So we know we have to get an answer that's less than 4 ohms when we're done. Otherwise, we've made a mistake. So we're going to go ahead and proceed here. 1 over our total in parallel was 1 over 4 plus 1 over 8 plus 1 over 12. We're going to resist using a calculator. Use our common multiple technique here. And the common multiple of 4, 8, 12 in RP would be, let's see, 24 RP. Multiplying that by our first term, we get just 24. By our second term, we get 6 RP. Our second term on the right side, 8 goes into 24, 3 RP. And 12 into 24, 2 RP. Well, that equals, let's see, 6 plus 5, 11 RP. And at this point, we'll go ahead and use the calculator because it's not a nice, easy division, though. We know that it's going to be just a little bit greater than 2. So, RP, 24 divided by 11. So RP is, go ahead and do that on a calculator, and we get 2.18 ohms. Okay, next they want the current in each resistor. The thing that we have to remember with parallel is that they all get the voltage supplied by the battery. In order to calculate the current, we need to know voltage and resistance, or 2 other electrical quantities. In this case, it's the voltage and resistance. And in this case, we know both. We know that each one gets 24 volts, and we know the individual resistance, so we can go ahead and calculate the individual currents. So let's go ahead and get started with that. We would call the current through resistor 1 I1 equals V over R1, 24 volts over 4 ohms equals 6 amps. I2, V over R2, 24 volts over 8 ohms equals 3 amps. And I3 equals V over R3, 24 volts over 12 ohms equals 2 amps. Really neat way for us to check this is off on the side, and it's a neat thing about current electricity is you can always check your answer if you take the time to do so. We know that the total current would be the total voltage divided by the total resistance. The total voltage is 24. The total resistance we found to be 2.18 ohms. And so the total current, when you divide that out, is 11 amps. Well, 6 plus 3 plus 2 is 11 amps, so your answer checks. All right, that'll do it for number 8.